And sharing screen. All right, so before I actually jump into the notes themselves, I just want to do a quick, brief review on the actual exponent action. What does an exponent do? And so the way I usually illustrate this, and if you've had me before, you've probably seen me make this table before when it came to exponents, but this is just the number 3 raised to various exponents. And what I'm going to do is I'm going to say what each one equals. This is mostly to illustrate why an exponent does what it does, and in particular illustrate why negative exponents do what they do, and why raising something to the 0 power doesn't equal 0, which is probably the most common mistake when it comes to exponents. So again, in our chart right here on numbers being raised to an exponent, this chart, by the way, is on the notes. I'll show you in just a second. I just want to do this illustration first. Let's kind of start with the ones that we know. Okay, for whatever reason, on this chart, this tends to be the one that most people latch onto. Most people have their squareds memorized. So 3 squared, many of you will know, is 9. Okay, that equal sign is going to be annoying. So 3 squared is 9. All right, most of us are familiar with that. Again, what that squared means is literally the number multiplied by itself. 3 times 3 is 9. Okay, and most people are comfortable with that. The other one that people tend to be comfortable with is anything to the 1 power. 3 to the 1 power is just itself. There's just 1 3. And that tends to be a confusing piece for a lot of people, or at least a point of confusion, in that they think in terms of 3 to the 1 power is 3 because it's 3 times 1. That's not true. Again, the exponent tells me how many times a number is multiplied by itself. The fact that there's 1 just means that it's just talking about that single 3. It's just the 3 itself. So anything to the 1 power is just itself. And then this one is kind of easily enough solved for. 3 cubed is just taking my previous value and multiplying it by 3 again. Or if you do it the long way, where you're 3 times 3 times 3, you'll get to this result of 27. Okay, these tend to be the ones that most people are comfortable with. And what I want to point out here is that if I were to expand this chart further and increase the exponent, the way I would find my next value going this way down would be by multiplying the previous value by 3. So starting here at 3, I multiply by 3 to get to 3 squared, multiply it by 3 again to get 3 cubed. If I wanted to go to 3 to the 4th, I'd multiply by 3 again, and I'd get 81. It's 3 to the 4th. And I could keep going. But the part that I want you to take notice of here is that if I were to go in backwards direction, if I were to start down here at the bottom and go this way, the operation I'm actually doing is called the inverse operation. So if I started at 27 and I want to get down to 9, instead of multiplying by 3, I'm dividing by 3. Okay? So in this case, dividing by 3 gets me to 9. Then dividing by 3 again gets me down to 3. And if I were to keep going through this chart, I would keep dividing by 3 as I move that direction, as I reduce my exponent value. And so when I do that, and I take this 3 and divide by 3, well, anything divided by itself, 3 over 3, becomes 1. And that is why one of the most confusing pieces, or the most common mistake here, is most people will say oh, 3 to the 0 power, that's 0. No, it's actually impossible to raise something to an exponent to make it 0, unless the base is 0 itself. But in this case, it actually goes to 1. Because again, it's not multiplication, it's an exponent. It's its own math operation, okay? And again, the reason that happened is because going this direction, I'm dividing by 3. And so if I were to continue dividing by 3 to get to this 3 to the negative 1 power, again, the most common mistake here is to think that this result would be negative 3. Again, it's not multiplication, and my result will actually not be negative at all. But what happens here is that, again, as I'm moving this direction in my exponent, now when I divide by 3 again, it actually becomes 1/3. So what happens with the negative exponent is it actually moves it into a fraction. Okay, and I'll talk a little bit more about that. And then if I were to keep going and divide by 3 again, I'm actually going to get 1/9. And then if I were to do it again, I'd get 1/27. Okay, and what I want you to notice here is a second thing. Okay, first off, that as I'm going down, I'm never getting 0. I get into fraction form when I'm dealing with these negative exponents. But here's the other thing. Notice the values here as I'm moving away from this 0 power. So as soon as I have my exponent become negative, it takes the reciprocal of that value. Okay. Now, what happened there, and for anyone out there that's a Stranger Things fan, like myself, the way I describe this to those students is that as I go into the negative, I'm going into the upside down. Okay. And if you don't watch Stranger Things, you will not understand that reference at all. For those that do, maybe it helps. But what's happening is that as I divide by 3 and get into this fraction form, you can actually see that the negative third power is 1 over 27, whereas the positive 3 power was just the 27. In other words, if I were to expand this down one more to go to 3 to the 4th, where 3 to the 4th would be 81, 27 times 3. 3 to the 4th is 81. 3 to the negative 4th up further would just be 1 over that result. So here's the benefit when it comes to dealing with these negative exponents. You can just deal with the positive exponent, which I'll show you how to do that in the calculator. And once I have that exponent, like raised to that exponent in the positive version, if it's a negative exponent, just flip the fraction. Okay. So anyway, that should be a little bit of review about exponents. Let me jump into the notes now. Okay, and again, here's that illustration. This again is on Google Classroom. There's my chart with the 3s that we just went through. I went ahead and did one with 5 as a base just to kind of show you how the numbers change. Again, nothing's really magical. It's happening here. Like now these are just multiplied by 5 as opposed to it's just the base. But again, you can see the illustration here. 5 to the 1 power is positive 5, it's itself. But 5 to the negative 1 power, it takes that 5 into a reciprocal. It flips the fraction, okay? So that if I had 5 cubed at 125, 5 to the negative third should be 1 over 125. Okay, that's the pattern that I want you to see there, and that will pop up in your assignment. These tend to be very, very quick solutions for these kinds of problems, and you'll see that as you get practice with them, but it's important to understand that kind of pattern as to what's going on, okay? So a couple of kind of punchlines to pull out of this illustration. First off, anything to the 0 power is always 1. Anything to the 0 power is always 1. It's probably simplest just to memorize that. Okay, the gut reaction is to say like anything to the 0 power is 0. Again, it's not multiplication. Okay, anything to the 0 power is 1, and it has to do with this pattern because it's dividing by itself to get back to 1. So no matter how complicated that base is, whether it's a decimal, fraction, or whole number, anything to the 0 power is 1. Anything to the 1 power is itself. That one tends to be a little more intuitive. Again, it doesn't matter how complicated that base is, anything to the 1 power is just itself. Okay? And then finally this, anything to a negative exponent, whatever the exponent is, my suggestion here, and if you need to write this to the side in your notes or in your margin or whatever, if you ever see a negative exponent, just deal with the positive exponent and then flip the fraction. So for instance, if you had 5 to the negative 3 power, just do 5 cubed, you'd get 125. And then because it was a negative 3 power, just put 1 over 25, okay? And there are issues with like fractions in there as well, but we'll jump to those when we get to them. Okay, so those 3 tend to be the major punchlines from that illustration. Let's move on. So I'm going to kind of skip these 2 examples right here. You can find those on the solutions on Google Classroom. Let me talk about this first, because this is probably what you're going to care a little bit more about. It's how to use the calculator in order to solve these exponents. Because one thing I want to emphasize is that on my tests, I always allow calculators and not like smartphones or anything like that. So make sure I have dumb calculators here when you need them. But make sure you have access to a calculator because it can come in very handy. But I wanted to show you guys on a calculator how I can do like customize an exponent. So for instance, -2 to the -4th. Most of us are comfortable enough finding somewhere on our calculator like the squared button, right? So if I have to do like 19 squared, most of us can find the squared button, which it'd be right here, okay? On my dumb calculator, it might be somewhere else in yours, okay? But what happens if I want to customize my exponent? There's a button on a calculator. I'm going to show it to you, zoom in right here. This button right here. Every scientific calculator will have one of these, okay? It's an X to the Y button. Using this button will allow me to customize not only the base of my exponent, but also what power I'm raising it to, okay? And particularly for this section, if you can track that button down in your calculator, this homework assignment will go by super quick, okay? And I think even the calculator on Big Ideas has that button on it, so you can actually use it as it is. But let's go ahead and try it in practice. 6.7 to the 0 power, this should be an automatic, that should just be 1. But let's go ahead and plug it in our calculator just to check. I would start with my base, and then I would press this X to the Y button. You'll see my calculator blink, and it's now waiting for the exponent I'm raising that base to the power. Now in this case, it's just the power of 0. So when I hit equals, there's the 1. Okay, not terribly surprising there. Anything to the 0 power should be 1. Okay. Now this one, -2 to the -4th. Let me give you the strategy for this because you're going to come across a couple with negative exponents. The main thing I want to emphasize again is up here, negative exponents, you're going to get a fraction. And Big Ideas is going to want non-decimal answers. So here's how you can go about doing this the easy way. Okay. I see that there's a negative exponent. Great. I automatically know it's going to be a fraction result, okay? So let's just focus on doing -2 to the +4 power, and then whatever result I get, just flip that fraction, okay? So that's what I'm going to do. So on my calculator, I have to do it this way, where I put in the number first and then add in this negative sign. Some of your calculators, you might be able to put the negative sign first, but there's my base, -2, and now I'm going to raise it to the 4th power. Maybe you know how to do that in your head or on a piece of paper, that's fine. This is just how to do it quick. So raised to the +4th power gives me 16. So just double checking that, -2 to the 4th power is the same thing as saying -2 times -2 times -2 times -2. Well, -2 times -2 gives me +4, -2 times -2 gives me +4, 4 times 4 gives me 16. Okay, so it made sense getting there, but again, the calculator can do that for you. But again, that's -2 to the +4th. Looking back here, because it was a -4th, I just know my result is going to be 1 over that piece. Okay, so that's how I would recommend doing that. Anytime you have these negative exponents, worry about the positive exponent first, because you can do that on a calculator, and then just put 1 over that result. And that should give you the correct answer. Okay, all right. Let me move on. So next up, I'm going to go through a couple of properties. I'm going to go through these pretty quick. Just make sure you slow down the video or revisit the video if you do need to take a little more time studying on this or I go too fast. So these properties should have been things that you covered in a previous exponents class when you were probably first introduced to exponent, the actual exponent operation. So let me just breeze through these really fast. Some of these you'll be familiar with. If ever I have a common base, that's what the A's mean right there. Okay, so that base could be anything again. It could be a variable like X or Y or A, or it can be a number like a decimal, fraction, whole number, doesn't matter. But as long as it matches the other one, okay? So in this case, A to the 3rd times A to the 4th. When I have this multiplication happening right here, the simple property is just add the two exponents together, okay? Here's why. Here's like the long illustration. A cubed is the same thing as A, or A times A times A. A to the 4th is A times itself 4 times. And since it's all just one long multiplication string, I can just count the number of A's, and you can see that that would turn an A to the 7th. Well, that property would have told me at the beginning I could just add the 3 and the 4. So now it's A to the 7th, okay? So that's the first. This one deals with subtraction of exponents, and I'll let you look at the illustration right there. Again, the tricky part with this one, just make sure you're subtracting numerator minus denominator, okay? Top minus bottom, top minus bottom. So in this case, I had 3 A's on top, 4 A's on bottom. They end up canceling those pairs of A's, and I'd have 1 A left on the bottom that can also be rewritten as A to the -1 power, okay, because that -1 power means it takes it into a fraction form, right? And so I could have done at the very beginning 3 minus 4, and that's where I would have gotten the -1 exponent. Okay, so be aware of that. Also be aware you're going to be asked quite a bit to put things in positive exponent form. And so if you ever do come across a negative exponent, the simple task is just put 1 over that value to whatever positive exponent. And I'll show you an illustration in a second. Okay, and then the third property here is what happens if I have an exponent raised to another exponent. Okay, and you can see the illustration here. A cubed, again, there's a times a times a. Anything raised to an exponent is just that something times itself that many times. So there's my 4 groups of a. That's the 4th power. Okay, but again, it's just one long string multiplication. I count the number of a's, and I find there to be 12. 4 groups of 3. Okay, so what I could have done at the very beginning is just do 3 times 4. So whenever I have an exponent raised to another exponent, I can just multiply my 2 exponents together. You will be seeing several problems that kind of run through these examples, okay, these properties. So let me turn the page and get into our second page of notes here. So here we see examples that involve those same 3 properties. Just talking through it real quick. I see my common base. I have a common base times the common base. I can just add these exponents together to get my result. So 2 plus 6 is 8. So my result here would be 3 to the 8th power. Okay, that's the quick and easy, right? Here, again, common base, -4s. And again, since I have this in fraction form, in division technically, I would subtract numerator minus denominator. 2 minus 7. I'm going to get a negative number here. I would get -5. So technically my result here would be -4 to the -5th power. But again, it's going to ask for positive exponents. So how do I deal with that? Let me show you the solution sheet real fast. So here's that very same problem. Okay, there's my property that tells me how to deal with the division. I'm just subtracting the exponents. Okay, so I'd get -4 to the -5th power. So how do I turn that into positive? By putting it into fraction form. That negative now becomes a 1 over -4 to the +5th power. Okay, so this is likely what they're going to be looking for right here for that final answer. Okay, if they do want to expand it a little bit more, technically -4 to the 5th power is an actual number. In this case, it would be -1024. So that would be the fully solved piece, but this again is how it would be reworked with the positive exponent. All right, and then lastly here, again, I can see an exponent raised to another exponent. It'll always look something like this, where it's in parentheses and you see the exponent outside. Again, the property there is to multiply those together. So I would do 4 times -3. That gives me -12. I'd have x to the -12th power. Again, to make that positive, I just drop it into fraction form. 1 over x to the +12th power. Okay, all right, 2 more properties to burn through right here. These have to do with distributive properties dealing with my exponents. So in this case here, I have any number of objects that are raised to some power. Okay, in this case, I have a times b raised to the 3rd power. Okay, so in this case, now my ab is multiplied by itself 3 times. So this is kind of the long way about going about it. Right, I can regroup those a's and b's so that a's are together and b's are together, and we can see that it's basically just distributing in this exponent. So ab cubed, or any number of things that are multiplied by each other cubed, I can just put the cubed over each object, okay? And so we'll see an illustration of that in a second. And then when it's in fraction form, it's the same thing. Again, it gets distributed in to each object. Now it's just in fraction form, okay? So a over b quantity cubed would be a cubed over b cubed, okay? Both of these are just how to distribute an exponent. And so these are the properties around that. Again, you should have seen these properties at some point in your math career. This is just a refresher on that. And so just illustrating a couple of quick problems, I'm just going to do these bottom 2. They're a little more difficult. There's a little bit more happening. I want to show you how to solve like the most difficult versions. So let me do, actually, I'm just going to do one example and we'll go ahead and call it after that. I'm going to do this example right here. 3d over 2 to the 4th power. So here, would be a problem that you might see on my test, hint, hint, where it would say simplify or perform the operation. Basically, you're going to simplify this, pull out, like you're distributing in this exponent and you're simplifying as much as possible so that I have only positive exponents, okay? So there are actually two properties at work here. First, I see my fraction quite obviously. And so based on my properties, I can distribute this exponent into both numerator and denominator. And so my 3D numerator is raised to the fourth power over 2 to the fourth power. Okay, there's my property with the fractions. That's the distribution of the exponents. Now, the second property I could use here is that this is multiplication. Okay, 3 times d. And that exponent's going to be distributed into these guys as well. So that would actually translate into 3 to the fourth power times d to the fourth power all over 2 to the fourth power still. So do you see how the exponent has been distributed throughout the object that's been multiplied by itself? Okay. And then as far as simplifying it, technically this is simplified, but on big ideas that they ask you to actually perform this, because 3 to the fourth is actually a number, 2 to the fourth is actually a number. This would equal 3 to the fourth on a calculator would be 81. D to the fourth does nothing because we don't know what D is. And then 2 to the fourth would be 16. Okay, quick hint here, because at this point you might be wondering, like, I have no idea whether or not 81 over 16 reduces at all as a fraction. The hint there is that if your fraction will reduce, it'll reduce at the beginning. 3 over 2 does not reduce, therefore 81 over 16 will also not reduce. So that's a kind of a quick check there as well. All right, I'm going to stop sharing and end recording.